So now we are going to move on to our third session with Aaron Stevanus. Aaron is the Technical Sales Manager of Eastern Canada at the Mosaic company. All right, take it away, Aaron.
Thank you very much. Glad to be here, and appreciate everyone having the time and taking advantage of this great opportunity that FS Partners has put together. I'm also going to turn on my webcam for the first part of the presentation, so you see that I am here. Hi. I'll also take it put it on for questions at the end, and I'm just going to make sure that I'm sharing the correct screen. Perfect. All right, so I'm here to talk to you today about balanced the importance of 4Rs in balanced crop nutrition. As mentioned, I'm the Technical Sales Manager for Eastern Canada with the Mosaic company. And please do write down my email address, as you can see here with the arrow, and also my Twitter account. Please, if you are on Twitter, follow me. I always enjoy seeing what's going on across Ontario. And also, we have a little contest that we're going to talk about at the end of the presentation. And also, there will be one prize allocated out. So make sure you write down my email address in case you are the prize winner, so you can email me your information. So a little bit about myself, if you don't know who I am a family of 4. That is on the bottom left corner is my wife, Anne McCrae. She is with BASF as a technical development person for horticulture. So if you are in horticulture, you may see her in the field or bringing new products from BASF. And our 2 children, Hannah and Isaac, with us there are our free labor on our farm, are also our children that we love to spend time with when we're not working. As mentioned, a farm, I'm the 4th generation in a small farm outside of Bloomingdale, Ontario, which is just outside of Kitchener-Waterloo. And there we do a little bit of mixed cropping with cash crops and also some vegetables. So we do sweet corn at a roadside stand along with pumpkins and other curcubits and potatoes. A part of our operation, as you can see in the top right, is we're along the river, the banks of the Grand River, and we find that cover cropping and nutrient stewardship is a very important part of everything that we do. And that's why 4Rs is very important to me, and because we want to sustain our environment and also grow more food and higher yields so we can produce the food as our population grows, but doing it with good environmental stewardship. And on the picture below that, you can see I have a small operation. So we have a small tractor, but it is probably the most expensive 4-row 7000 that's attached to that with lots of precision attachments. So I'm using multi-hybrid variable rate with precision plant VSET selects. And then I also have a Rawson drive to do variable rate fertility. In my previous career, I was in the seed industry. So we were looking at how does seed fit into precision ag, and now being in fertility, you'll see information coming this year on my Twitter account and also maybe in presentations in the winter on how we can apply fertility into variable rate applications on the planter. I'll have a couple of locations where we'll be doing that, and the results will come this fall. I'm also from the University of Guelph, graduated in 03A and 07, and was a CCA in 2009. Since 2009, sorry. So I'll shut off my webcam now, and we'll get into the meat and potatoes of what we're going to talk about in this brief 20 minutes. So I'm going to give a quick overview of who the Mosaic company is, and then also why we're so invested in 4Rs, and also for our stewardship on what's going on in Ontario. And then we're going to talk a little bit about performance fertility and 4Rs synergies. So how does fertility really fit in to 4Rs, and maybe some of the choices you can make on products that really makes 4Rs a lot easier. So starting off with the Mosaic company, who are we? We're a company that we produce fertility products. We're traded on the New York Stock Exchange as MOS, and our mission is to produce the food, help the world grow the food it needs. And a part of that is our work, and really we want to drive our products and our solutions to be able to help growers grow more food for the population that continues to grow. So how do we get there? We are the largest producer of finished phosphate and potash production in the world, and we have a 26.6 million ton capacity of operation. For North America products, we have two lines, one in Canada. So our potash is all produced here in Canada, in Saskatchewan. And we have just came online our K3 mine, which is the most efficient potash mine in the world. Also, phosphate is produced in Florida. So all of our phosphate production for North America is in Florida, and we also have mines in Brazil and a couple of joint ventures in Saudi Arabia. When I talk about phosphate and potash, our main products are DAP, so diammonium phosphate, MAP, monoammonium phosphate, and micro essentials, which we'll talk about later on in the presentation. On the potash side of things, we make muriate of potash, which you're all familiar with. Spire, which is potash with enriched with boron. K-Mag is not produced in Canada because that is a specific ore body that is only found in Carlsbad, New Mexico. And Pegasus is produced in Canada. It is a white potash with a little bit higher load. So that's a little bit about us, but how does this all what makes that different? How does this all kind of come together? Well, we at Mosaic feel that it's not only important to produce fertility, to help feed more people, but also to ensure good environmental practices and uses of our products. And we feel the three pillars of successful crop nutrition are as followed in the three balls that you see in the bottom, and that is experienced agronomists, innovative portfolio, and significant research. And I'll give you a little example of each of those. So for experienced agronomists, as you've probably mentioned, I've seen him or heard him talk before, is Ross Bender. And he was our focus in Eastern North America for agronomics leads. And now he's just taken on a new role of the new product development at Mosaic, because we continue to go into that significant research. We're continuing looking at new products and bringing on things that are profitable and provide good nutrient stewardship back to the grower in general. And then also our innovative portfolio, our premium products have produced better results and given us more efficient nutrient use, which I'll talk about later on in the presentation. And a part of that, like I said, is that research. So we're constantly looking at new ways to bring the products that we have to bring better ROI, but also to provide good fertility technology to make good environmental decisions, and also good return on investment, because we don't want to release a new product that does not have a good return on investment to those that are using it. So a little bit about our 4R stewardship. It's really based in balanced crop nutrition and supporting the 4R initiative. We feel that this is a perfect fit based on what we as a company at Mosaic believe in and strive for in our pillars. And we feel it's important to drive forward in good stewardship with fertility use. Just to focus on Canada, you can see Saskatchewan and Manitoba and Ontario is where we focus a lot of our nutrient stewardship footprint, and that's because those are the provinces that are heavily invested in 4Rs. We're working with over 10 organizations across North America, and we have had an impact on over 7.2 million acres across North America. Now, before I go into the next slide, I'm going to do an attempt of a giveaway here, as I mentioned earlier. So we're talking about 4Rs and the importance of 4Rs. Who can tell me in the chat what the 4Rs stand for? And what we'll do is I'll have a nice little giveaway that I will mail to you, and see if we can get what the 4Rs are.
Hi, we've got an answer in from Brett Israel. He said, right source, right rate, right place, and right time.
That is correct. Thank you, Brett. That is 100% right. And please send me an email for your mailing address and I will send you a nice little prize package. Thank you for the answer. So you're right. Right source, right rate, right time, and the right place. So it's important to focus on these. And I would say we want to focus in on each 4 of these before we move on. So let's look at the right source. So by choosing the right source, it's important to work with your FS Partners crop specialist to match the right fertility product to your crop demands. That's key. Next, moving on to the right rate, an example would be to work with also your crop specialist or your precision ag team if you have the capability to do so, which we kind of talked about earlier on in the bringing you what's next portion, is to match that right source and that correct rate. So if in a variable rate application, if we know based on our soil tests where we're at, then we can apply properly at the right area the right amount of nutrients for crop removal, once again based on soil tests. Finally, the right time. You'll see later in my presentation that the importance of nutrient timing of plant uptake and partitioning is crucial. So we want to make sure that that plant has the right availability of nutrients when it needs it. You're investing your money in fertility, and to have it taken up by the plant and lost to the environment is not a good return on investment and not good for the environment as well. So let's make sure that we're putting that fertility on at the right time. And finally, the right place. I would say this is a cornerstone, and I'm going to talk about it in a second on why we should have our fertility where it should be so the plant can take it up. Kind of similar to that right timing. We need to make sure that it's where it needs to be so we have access and the plant can utilize it. And we're going to talk also about that with boron later on in the presentation. So looking at 4Rs in Ontario in general, I want to let you know that it is a voluntary program. It is Ontario agriculture has stepped up to the societal challenge, we'll call it, onto managing our nutrients properly. And I might add that FS Partners is definitely leading the way in Ontario for us to get there. In the quote, research funded by North American 4R Research has shown growers in Ontario can reduce phosphate runoff by 60% by applying the 4R BMP. And I would say that if you even look at some of our local data by people like Maren McRae at the University of Waterloo, she very much echoes that. It's very important to make sure that we're doing that. And actually of that 60%, we can get there very easily by once again putting it in the right place. We can eliminate 50% of our phosphate runoff by making sure our fertility is placed close to the crop so it can take it up. So within Ontario, we currently have 31 retailers that are compliant with 4R certification and pre-audit, and 17 sites have completed full audits. Of that 17, 3 of them are FS Partners locations. They are fully certified. And in talking with Nicole, there are the whole organization of FS Partners does hope to be fully certified within the next couple of years, assuming everything moves along after COVID-19 the way it has in the past. Big shout out on that to Nicole and Megan. They both were very integrated into making sure certification and pre-audits happen correctly, and also to all the branch locations that their hard work, because it is a lot of work to get everything done and certified, and a lot of record keeping to make sure we are doing things properly. So good job on FS Partners in general, and good job in leading the way in Ontario. And just under 500,000 acres are recorded under the 4R so far in the certification program, and hopefully that continues to grow. So that's it on the kind of quick talk on 4Rs and how it applies to Ontario and what it means to us as the Mosaic company. Now I'd like to spend a little bit of time on talking about performance fertility and the 4R synergies. And before I do that, I just kind of want to give a maybe a little bit of definition of what I mean by performance fertility. And fertilizer in general, we provide it for crop nutrition, but sometimes we get synergistic effects between either two different nutrients on uptake, or sometimes having a better distribution. Really, we're looking specifically here at even nutrient distribution and availability, and we really want to have a payback. So it's kind of taking all that together, the 4 R's, making sure we're profitable, we're good environmental stewards, and also making sure the crop's meeting the demands that they need. And so that's what I'm going to kind of talk about, of the synergies of performance, fertility, and 4 R's. I might add that performance fertility comes from our performance product branding, which are the 3 products you see on the bottom of your screen: Micro Essentials, Aspire, and K-Mag. So you've all seen these graphs before. These are done by Ross Bender, our now new product development director. And you can see essentially on the x-axis here, we have our plant, essentially days after planting, or also it's done in growth stages. So we have the V to the R. So we have a plant emergence on the far left to R8, which is harvest. We have the nutrient uptake on the y-axis here, and the idea is to see when the plant needs the nutrient and how much it demands throughout its life cycle, but then also where these nutrients go within the plant. And I think this is very important because these tell us different things about nutrients within the plant. So it's very important to see, yes, we need season-long availability of fertility. This crop specifically, all these graphs are for soybeans, and I might add I'm specifically looking at potassium here. The top right is zinc, the middle here is phosphate, sulfur on the bottom left, and boron on the bottom right. So what we want to look at specifically, I'm looking at potash here, is we see a massive uptake, from essentially V8 all the way to almost the end of R8, probably coming into R7. We see a drastic intake of potassium. We also see, so we know that, we've seen that several times, these graphs are used time and time again on when nutrients move into the plant. But what we don't talk about is the partitioning. So what I mean by partitioning is these different colors mean where nutrients are within the plant. So this green means we're in the leaf, this yellow means we're in the stem and petiole, this red means we're in the flower and pod, and this blue means we're in the grain. So what we can learn about this is where nutrients move within the plant, and if they have the ability to move from different parts of the plant if we're deficient. So looking at potassium, we do see that there is a little bit of movement from the leaf into the leaf, stem, and flower into the grain as we move to the end of the R phase. So about R6, it starts pulling everything out of the plant and moving it into the grain. When you look at something like, let's say, phosphate, very early on, even at, say, R5, 5.5 into R6, we see a major movement out of the leaf, stem, flower, petiole into the grain. So these are nutrients that have the ability to move. If you look at something like boron down at the bottom, these lines are fairly straight as we go horizontally. And what that means is these are immobile nutrients within the plant. So if we were to say have a deficiency, the deficiency will show up at the top, say in the vegetative stage, because nutrients cannot move from the bottom leaves, the more mature leaves, up to the new growth. So this is important when we're talking about where we place nutrients, because this needs to be taken up from the roots, because even if you were to say put a foliar application of something like boron on, you're getting it onto the leaves, maybe under the stem, but it does not have the ability to move it within the plant. And as that plant continues to grow, it will not move. So something like boron, we can learn from these, is very important to move into the plant through the roots. So that's a little bit just on the importance of where we need to place nutrients and why it's important to get them into the plant. And then I want to spend a little bit of time here talking about the 3 Ds, which is something that Ross Bender came up with. That's kind of a practice on where we need to put our nutrients and how we need to prioritize based on 3 simple factors on proper nutrient management. And so the 3 Ds are as follows. We talk about distribution, duration of availability, and daily use. So I'm going to bring back to this one of the graphs that we used in the previous slide. And if we talk about distribution, so for example, this is boron, and boron is a micronutrient. So you don't need a lot of it. It's a very fine line between toxicity and having the right amount. And deficiency. So we need to make sure that that gets evenly distributed for all of the crop to take up, which makes it very hard. And having the ability to distribute that properly is going to be key, so we don't have toxic areas and deficient areas. Also, if you look at duration of availability, so if you look at this, we need availability of boron all the way through the season, because it's taking it up all the way from the vegetative, all the way through to reproductive, and it cannot move within the plant. So we need it in the root area. So once again, looking at that placement of fertility, it needs to be where it can take it up. And daily use, as we see, which makes sense as we continue to increase biomass, that plant is going to need more and more. So where are we going to apply fertility to when that plant actually needs it is very important to 4Rs, and making sure that we're also getting a return on investment on our fertilizer, and also that essentially we're getting the maximum yield we can out of this plant. So I'm going to go a little bit deeper into all 3 of these Ds as we move along. So I talked about uniform distribution. So I'm going to give an example of a product that we have called Micro Essentials, and I'm going to compare it to a blended product that would be, say, the exact same analysis. And our Micro Essentials is a 12% nitrogen, 40% phosphate, 10% sulfur, which is split 50-50 with ammonia, with sulfate sulfur, and elemental sulfur, and it has 1% zinc. So if we were to look at, say, our diagram here of a blended product, these white granules would be the monoammonium phosphate MAP. And if you can see, out of these 5 plants, because it's the biggest portion of the blend, almost all the plants, 4 out of 5, are all receiving that monoammonium phosphate. If we look at the black dots here, we can see that maybe half, 3 out of the 5, are receiving that ammonium sulfate. When we look at the elemental sulfur, because it's such a high percentage analysis, we don't put a lot of it into that blend. So really only maybe 2 of these plants are going to take advantage of that elemental sulfur once it oxidizes. And then once again, looking at zinc, really this one plant is only receiving that amount of zinc. The rest of the 4 are not. And you could arguably say that this is almost a toxic side, because we're looking at a micronutrient where these would all be deficient. When you look at Micro Essentials SZ, we have an even balance of all of these products right across the board. That's nitrogen, phosphate, 2 forms of sulfur, and zinc. So now we're looking at each of these plants. We have all these 5 plants, and each of them are all taking that same amount of nutrition right across the board, which comes down to that even distribution and the importance of us taking up what the plant needs at the right time. So I'm going to go into this a little deeper and challenge you a little bit on returning to high school chemistry. I know that it's all muted, but I'm sure there's groans there, because we all don't want to deal with chemistry. But it's still important to crop nutrition. And this is the major form phosphate, dihydrogen phosphate. And what we need to do is make sure that we're taking up dihydrogen phosphate over hydrogen phosphate. They both will be taken up by the plant, but dihydrogen phosphate is the preferred choice. So what happens is the plant has to convert hydrogen phosphate to dihydrogen phosphate internally, and so it takes less energy if the plant takes up dihydrogen phosphate. So if we can provide a source of phosphate that is in that form, we can be more efficient and utilize it better. And I'm going to skip this slide for the sake of time. And that's what MicroEssentials does. Because it has the ability to acidify that granule due to the elemental sulfur, we actually see an increase of phosphate into the plant because of having more dihydrogen phosphate available, because we are more acidic in that granule. So in these bars here, you can see we did a tissue test at V6 to V8, and we compared MAP plus ammonium sulfate and zinc sulfate, and MicroEssentials. So as you can see, between the differences, we see a 9.2 pounds of phosphate in the tissue sample. We see a 9.7 in the blended products. We do see an increase. We see that ammonium sulfate and zinc sulfate helping with the phosphate uptake. But when we look at MicroEssentials, all of them together in one granule with good distribution, we see a major, with fairly significant increase to 10.9. But if you look across, you think, yeah, it's there, but we're looking at decimal places. What does that really mean for yield? Well, if you look down at the bottom, when we start to look at yield, this is when we really see MicroEssentials, as said, sift out compared to the blended product and the straight MAP, because we have that distribution and everything taking the plant's ability to take up nutrients right across the board, across all of the plants, just like the distribution model that you saw on the slide previously. We also see synergistic effects when we look at two different nutrients together. So this is a greenhouse study. On the x-axis we have time, and on the y-axis we have concentration of solution. So what we had was we had two different plants side by side, and one had adequate levels of potassium with no boron, and adequate levels of potassium in the solution with boron. And what we see here, if we have low boron or no boron in the solution, now this is going to be counterintuitive. As you move down the graph, we're actually increasing our concentration. We're actually increasing, potassium into the plant, because we're taking concentration out of the solution that the roots are in. So if we're moving down, that means we're moving more into the plant. So when we have low boron, we see potassium not moving into the plant as efficiently as it could be. When we have adequate levels of boron, we actually see a major increase of potassium moving into the plant, and therefore keeping it adequately nutrient availability. And that's simply by making sure we have enough boron there in the root to help get it into the plant. So these are the kind of the cool synergistic things we can see as we start to make sure we have the right nutrients and balance out crop nutrition. So it also helps with our 4 R's when we're looking at what do we apply and making sure we're using our nutrients properly and in the right place as well. So that is the brief outline on what we're talking about, on how do we get the synergistic effects with selecting the right fertility and using the 4 R's. And I'm just going to talk a little bit now about the yield results and trials that we see to kind of bring this all together and to make it concrete, so we can truly see that there's an ROI when we're talking about choosing the right fertility products in 4R practices. So in general, when it comes to Aspire, Aspire is our potash that's enriched with boron. We see a 5 to 8 bushel increase across all the trials we've done across North America at 100 pounds per acre of boron. If you look at soybeans, it averages around that, say, 2 bushel increase with 100 to 200 pounds. And winter wheat, we're actually seeing a 3.3 bushel increase. And our real major winner, if you're really looking at fertility and boron, is alfalfa. We're getting half a ton to 0.8 ton per acre increase at different application timings throughout the season, usually split after first cut and also at the end of the season. So when we look at K-Mag is our blended product of potassium, magnesium, and sulfur. This is a really neat trial that's we've just finished, and we do have one location here in Ontario, and that's really looking at this demand of not only magnesium but sulfur in soybeans. As we continue to increase yields, sulfur is continue to be a major component of soybean yields, and as we've already known before, grasses like corn and wheat. But we're finding as we push yields higher and have more demand for sulfur, we definitely see a return on investment for sulfur in soybeans. So if you want to just look at the yield information here on the right, we have our control of nitrogen and phosphate at 555 bushels. We have just straight muriate of potash at 56. So we see a 1.3 bushel increase by adding potassium into soybeans, which we know, especially drought conditions now, you really see where we say have deficiency of potassium and we're not getting it into the plant. Potassium is a huge component to soybean yield and fertility. But we see by just adding, so what we did is we had 60 pounds of potassium and muriate of potash. We simply took 10 pounds of actual out and replaced it with K-Mag. So we still have that 60 pounds of actual potassium, and we're just adding a little bit of essentially sulfur and magnesium into that, and we see a nice increase of about 2 bushels by just taking that a little bit of muriate of potash out and adding K-Mag. So once again, that sulfur and magnesium is pretty important as we see yields continue to increase, moving over that 50 bushel mark in soybeans. And finally, I had mentioned earlier that we're looking at different fertility options in precision ag, that I have a couple of initiatives myself going. And across North America, we've been noticing that just like the muriate of potash or the potassium and boron, the synergistic effects between nutrients, we're seeing that across also with our performance products, so Micro Essentials, Aspire, and K-Mag. When you blend these products together, there seems to be a synergistic effect. In other words, a 1 + 1 = 3. And here's an example that we had in the U.S. This is specifically in the United States. And what we did is in soybeans, we had 100 pounds of Micro Essentials, 100 pounds of Aspire, and 50 pounds of K-Mag. And for corn, we were using 150 to 200 pounds of Micro Essentials. This is depending on soil tests to make sure we're not overapplying phosphate, and 100 pounds of Aspire and 50 pounds of K-Mag plus whatever source of nitrogen you chose. Specifically, if you look at this soybean example here, we did some satellite imagery at canopy, and then at the beginning of canopy, full canopy, and then as we start to move into the defoliation. And you can see, so when we had these products together, this block here, we had faster canopy closure. So essentially we were utilizing the sunlight, and we're not wasting on the ground faster. So we're essentially putting more into producing soybeans. As you can see, that continued on within the season. We see better plant health and development in this block. And we actually see, as we keep that crop fertilized and meeting all demands, think of those graphs that we showed earlier on plant demand and when it needs it, we actually saw that it finished a little earlier than everything else. And what we saw was a 4.5 bushel increase, which is 2.5 to 1% ratio, our ROI ratio, and that net return on investment was $25 per acre. So we're really seeing that synergistic effect when you add the right fertility together and provide balanced crop nutrition. So that's that's the end of my presentation. And what I'd like you to challenge you at is to think differently. And you may be used to, we heard earlier, you know, Corey talk about, you know, set it and forget it. Well, we can't have that mindset anymore. I want to challenge you to think differently about how you fertilize, how you look at your crop management system, and also make sure we're looking at it from a 4R standpoint, and make sure we're using the right products to get to where we need to be, and let your agronomy work for you. Not only, you know, profitability wise, but also environmentally. I think there's a fine balance that we can find where we can be more profitable and environmentally friendly by using good agronomy, and work with your team, surround yourself with good people, and work with your crop specialists and precision ag specialists at FS Partners to achieve this victory that I think you can do. Once again, thank you. My contact information is below there. And finally, I just want to do a little plug on an Aspire contest that I'm doing on Twitter called the Grow On giveaway, or I'm calling it Grow On with Boron. All you have to do is take a picture of your planting, application, anything where you used Aspire in your field with the hashtag Grow On and a hashtag of Aspire. And we have the chance, that'll give you a chance to win a crokinole board, and also 2 other giveaways of an agronomy bag, just as a fun contest to show how Aspire is working in your field. And that'll be running until the 20th of July, sorry. So please enter if you have the chance, and thank you for the time. And if there's any questions, I'm definitely welcome the questions.
Awesome. Thank you so much, Aaron. So at this time, we've got a 5-minute sort of window that we have set aside for any questions. So if you have questions, you can type them into the chat box or into the question box, and we will facilitate that for you. So we have a question that has come in. What alternative is there for microessentials when phosphate levels are adequate on livestock farms?
That's a good question. So essentially you're asking, to repeat it, is what else is there for phosphate levels if they're high enough on agriculture, on livestock farms? So obviously we're probably looking at something with, I'm assuming, a poultry manure or a hog manure that's higher in phosphate. And I would say really it comes down to talking with your crop specialist to make sure that your soils are soil tested, because we want to make sure that where your phosphate levels are, that if they are too high, then we need to manage your phosphate application appropriately. And then from then on in, I would say the neat thing, so beyond microessentials, there is MAP that you could use as just a straight 11-52-0. But really, when you look at a higher phosphate rate, and if you are applying, say, specifically in a 2x2 band or a strip till, which is once again important to make sure you're having it at that right placement at the root zone, we're finding that microessentials, because of that availability to have that dihydrogen phosphate and better phosphate availability, the efficiency, you can get away with less, which kind of fits in well to our 4R standpoint. But once again, I defer back to working with your crop specialist, because there's lots of different things like pH and CEC and organic matter that are going to have an effect on your phosphate, also your tillage practices. So I would almost have to defer back to having that talk with your crop specialist to make sure you're putting the right source and the right rate of phosphate down.
Awesome. Thank you, Aaron. If there are any more questions, we'll take another minute. And if not, we still have that 15-minute window at the end of all of our sessions where you can ask a question. So we got one more in. It says, how do you get right place in no-till soils?
Right place in no-till soils. Great question. No-till in general is that how do we get the right placement? And so it's going to come down to, essentially, depending on what type of planting equipment you're using, you're going to either want to be in a 2x2 band if you're using a planter, which there seems to be less of those with dry fertility on say a 15-inch row. or we're going to want to have fertility right in the band. Say if you're using an air seeder, you have that ability to put it right in with the seed, and on some grain drills you have that ability as well. Either that, if you have the ability to go to wider rows like a 20-inch row, you can do a strip till. In general, it is a challenge because we don't want to broadcast that phosphate. Sometimes people will maybe over apply in a 2x2 band. Once again, looking at 2x2 band in corn, but still, it is definitely a challenge. And yeah, I think it's going to come down to looking at different methods on equipment, depending on the size of your operation and what your cash flow allows you to on getting it into the right place. But yes, I would agree that is a challenge. Not really knowing what your operation is. I'd be willing to talk with you offline about it, but I think there are some options, but it depends on what your ability is for your operation.
Awesome. Thank you so